We are given that this is a function. We want to know, is it a one-to-one function? If it is, let's find its inverse. Now, by the way, this is a linear function, so is a linear function one-to-one? Does it pass the horizontal line test? Remember, every single line except two special lines are one-to-one functions. Horizontal lines, those are functions, but they're not one-to-one functions because they don't pass the horizontal line test. And what about vertical lines? Well, vertical lines are not even functions. So every other line is a one-to-one function. This is not a vertical line, nor is it a horizontal line, so it is a one-to-one function. And now let's find the rule for its inverse. Normally, if this is written as f of x, we would first call this y just because it's easier to manipulate y than f of x. Then to find the inverse, we simply need to switch variables. Every time there's a y, replace it with x. Every time there's an x, replace it with y. Believe it or not, this now gives us a rule for finding the ordered pair solutions of the inverse of this function, because all ordered pairs will be switched from ordered pairs of this equation. We would like this, though, solved for y, so let's take a moment and solve it for y. I'm going to add 2y to both sides, so I'll have 2y plus x is equal to 6. Then I will subtract x from both sides, and I'll have 2y is equal to negative x plus 6. To solve for y, I'll divide both sides by 2, and I'll have that y is equal to negative x plus 6 all over 2. Let's suppose this is our function f of x. Then to show that this is the inverse of f of x, we will write f inverse of x, simply a notation, and that equals negative x plus 6 all over 2. This is the inverse of our original function.